Okay, hello everyone. Thank you all for joining us today. I have 12 o'clock, so we are going to get started. Welcome to the Water Ambassador Program. Water Ambassador Program, for those who may not be familiar, is a partnership program between Martin County and University of Florida IFAS Extension Florida Sea Grant Program as a way to promote best practices for Florida's residents to protect and promote water quality. This is our upcoming Water Ambassador virtual webinar series program for you. We have some great webinars coming. The next one is on oyster prisms, a plastic-free oyster reef structure project that our colleague at University of Florida IFAS is working on. And then some other great ones. We'll be putting the registration link in the chat, so just be patient with us. We also have on March 1st, our first Water Ambassador graduates field trip to the Jensen Beach Restoration Impoundment Project. So we're going to be getting a tour of that, and we will put the registration link for that in the chat as well for those of us who are local and are able to join us on Tuesday, March 1st. So just as a reminder of the Zoom platform, although by now everyone's probably experts at this, your microphone is muted by default, and we do ask that you keep it muted. If you're having audio issues and you can't hear me now and you just see my mouth moving, click that little up arrow caret to adjust your audio settings until you hear me. You do have the ability to start your video, but we ask that you don't. This helps with bandwidth issues and prevents distraction. You are free to start the video during the question and answer session at the end if you'd like. Just in case you want to see who's participating there, you can click on the participant list. All of the registration links, as well as any questions, are going to be put in the chat box. And if you need to leave the meeting at any time, just click on that leave meeting on the right. And we suggest the side-by-side mode for the optimal viewing settings. This allows you to see both the speaker and the presentation in the best mode. We will be recording this and posting it on the Martin County Sea Grant website, which is extremely long and complicated. So we will also be putting that recording link in the chat in just a few moments. And just a reminder, please use the chat feature to ask all of your questions. We will be holding all of the questions until the end. And with that, I am pleased to present our dual speakers for today, both coming from the Florida Oceanographic Society, talking on enhancing oyster restoration through assessing the impacts of living docks and oyster gardening. So we have Sarah Cole, who's a research associate interested in marine larval ecology and molluscan shellfish restoration. She believes that one of the best ways to have successful restoration is to involve the local community. Sarah received a BS from Eggard College in St. Pete and her MS degree from the University of South Alabama in Dauphin Island. Sarah has spent time in public education and outreach, polychaete embryology research, as well as performing shellfish restoration in northern Florida. Her current research interests include oyster reef monitoring and restoration efforts and their ecological impact. Morgan Gilligan is a research associate interested in new and innovative ways to improve conservation and restoration techniques of marine ecosystems. She received her BS in marine biology from Stockton University, New Jersey, and an MS in biological oceanography from Florida Institute of Technology. For her master's, she was involved with the Citizen Science Initiative studying the efficacy of oyster restoration mats and their succession over time. Her current research is focused on clam and seagrass restoration, helping to improve the quality and diversity of local living shorelines. So we're really excited to have both Morgan and Sarah here today presenting on their project, and I am going to turn it over to them. So thank you, ladies. Sarah, you are muted.
Thank you. So thank you, Lisa, for that introduction. Morgan and I are excited to share today our new project as well as
Morgan, can you mute yourself? We're getting feedback, I think, from both of you being unmuted.
Perfect. Let's see. So we're excited to share today our project and our research that has been done in the past, as well as something we're looking forward to do here in the Southern IRL and St. Lucie here in Martin County. Let's see, is it loading?
Not yet. We're still seeing your working screen.
There we go, right?
Yep, there it is.
Perfect. All right, so I'm Sarah, this is Morgan, and today we're going to talk to you about the oysterization using living docks and oyster gardening. So to give you a quick outline of everything we're going to talk about today, we'll first start about the current estuary health that we have in the Indian River Lagoon overall, as well as focusing on the St. Lucie estuary. Then we'll talk about what is a living dock, how are they used, why are they important, why do we care, as well as previous living dock studies that have been done in the Northern IRL and why we want to bring it down here. And then I'll speak a little about what oyster gardening is, and then finally I'll go over what our project is that we're starting here in the Southern Indian River Lagoon. And with that, Morgan will take it away.
Hi, thank you. Thanks so much, Sarah. So as we know, ecosystem services supplied by the IRL have depleted, mainly due to the influx of freshwater discharge and urbanization around our coasts. And as a result of that, there's been an increase in harmful algal blooms, loss of our natural ecosystems, such as oyster reefs, seagrass beds, your mangroves, and in place have been more man-made structures, such as your docks, jetties, bulkheads. The northern portion of the IRL, you have more of an accumulation of fine grain organic sediment known as IRL muck. And this sediment is very anoxic. I'm sorry, I don't think someone's on mute. And anyway, in the southern portion,
I'm going to mute everyone. It may accidentally mute you, so you might need to unmute yourself.
Perfect. I would keep. Alrighty, thank you so much. I was saying, in the southern portion of the IRL, sorry, technical difficulties, it's a little slow. So I think, Lisa, it may have frozen, so I'm going to try and maybe reshare it on my computer if I can.
Okay. Yep, you should have the capabilities.
Okay, we'll give it, go ahead, give it one more time, Sarah.
And while we're waiting for that, Vincent and I will be putting up the registration links for our upcoming webinars. So.
Perfect. All right, we're back. So in the southern portion of the IRL, we have the freshwater discharge leaching over from Lake Okeechobee. In the figures that you're looking at now, you'll see a time series from 1984 versus 2020. And what I mainly want you to look at is the increase in urbanization, especially around the Forks, in this area down here, close to Florida Oceanographic. And so the increase in urbanization also does not help our harmful algal bloom problem due to the fact that excess nitrates and phosphates are leached into the system, more so through fertilizer. Alrighty, so when you think of benthic communities, you probably think of your more popular communities such as oyster reefs, seagrass beds, or mangroves, but you may gloss over the fouling community in general. And just like these other ecosystems, the fouling community also is mainly composed of suspension feeders, meaning they take in particulates from the water column and then eject them as feces or pseudofeces. So ultimately, they are cleaning the water and also creating nutrients for organisms that live on the bottom topography and create fine grain sediments through their feces and pseudofeces. Some popular ones you may know of are oysters, mussels, sponges, barnacles, and tunicates, which are your sea squirts. So overall, the IRL has a very vast benthic community. And this is partially due to the fact that we sit at a biogeographic transition zone between warm, temperate, and subtropical climates. And so the community in general is exposed to high stress environment from daily tidal fluctuations, ambient seawater conditions, and they all react differently to these changes. The figure to the right here is just a few common organisms you may have seen or you will find in the IRL. We have an anemone in the middle there, followed by an encrusting bryozoan, which will appear in either an orange or a white, crusty kind of feeling organism, followed by arborescent bryozoan. And then we move around and you'll see sponge, there's the orange dots, and then a plethora of barnacles. You'll find those a lot of places. And then finally, green algae. So to combat the decline in natural ecosystems and the decline in water quality, the Living Docks program was established in 2013 at Florida Tech with the mindset of letting nature do the work. And so the process consists of wrapping oyster restoration mats around dock pilings. And oysters are a nice natural hard substrate for organisms to settle onto. And Florida Tech also paired their program with restaurants, so they ended up recycling the shells so they didn't end up in the trash or landfills as well. And so the process begins by traveling to communities and giving a community presentation and also analyzing the dock to make sure they are a good fit. From there, we move on to our oyster mat workshop, where the mats are constructed with the citizen scientists. And then later we move on to the deployment, where the mats are actually wrapped around dock pilings. And you might be thinking, why dock pilings? So there's actually a few benefits involved from suspending the mats off the sea floor. So for one, you do not need a permit, so there is no delay in the timing of your restoration project or process overall. There's no competition between species. So let's say there's a seagrass bed on the seafloor and your mats are not in competition or degrading the health of that ecosystem either. And then finally, in the northern portion of the IRL, there is the IRL muck that frequents there. So the mats are not in contact with this fine-grained sediment and therefore will not succumb to this deadly sediment. Overall, it's an easy to follow process. And we do conduct a follow-up assessment after the mats have been deployed. And anyone can take part in this, from children to adults alike. It's a great way for the community to come together to help restore local water quality and clarity. So currently there are 13 living docks spread across the IRL. A majority are in the northern IRL. For my thesis work, I had the pleasure of analyzing 9 of the 13 locations across 2 time periods. But for today, we're going to focus on 4 locations where I had the ability to go out and analyze another time series, so 3 total. And those are Cape Canaveral, our northernmost dock, followed by Melbourne Beach, Melbourne Shores, and Sebastian, our southernmost location. And all the docks I was able to analyze 6 mats, excluding Sebastian, which I analyzed 4 mats. And all of these docks were deployed between the years of 2017 to 2019. So some questions I wanted to ask following this research were, what organisms have settled on the mats overall? Is there a difference in community composition, north versus south? How do the benthic species vary spatially and temporally? It's the same thing. Is there a difference from the northern location versus the southern location, if there's a dock near an inlet? And temporally as well, do the communities differ seasonally, and what triggers, what species to spawn during what temperature changes? And finally, have the mats acquired a significant amount of growth to become cemented to the piling? So are they able to eventually become secured themselves via benthic organism growth? So I analyzed 10% of the entire dock, which was the 6, excluding Sebastian, which was the 4. The front and back of the mats were photographed. and 6 shells on each mat were analyzed across 3 seasonal assessments. And these individual shells were denoted with a colored zip tie. October 2020, February 2021, and June 2021. In terms of mat cementation, organisms such as sponge, encrusting bryozoan, and barnacles were noted to aid in cementation. There were also oysters present, but these were not included in the study due to the fact that they seemed to grow on the mesh itself and grow outwards, so they did not aid in cementation. And all of these calculations were conducted through ImageJ. So overall, the benthic community composition, I ran a Permanova through R and found that there's a significant difference for both season and location. A simple analysis, which showed which species were driving the change due to temperature, was found to be barnacles, biofilm, encrusting bryozoan, and oysters for the October assessment, which was about 80 degrees Fahrenheit. On the right here, you can see Cape Canaveral, which was our northernmost location, versus Sebastian, our southernmost location. You can see that Cape Canaveral has an influx of barnacles, but as you start to make your way south on the graph here, you can see that Sebastian has more of an evenly distributed community the more south you go. For the February analysis, the simper analysis revealed that encrusting bryozoan, biofilm, oysters, barnacles, and sponge were the organisms driving the change due to temperature. And this was our coolest assessment at 64 degrees. Looking over to our figures on the right, the photos, you see Cape Canaveral. Canaveral is encapsulated by encrusting bryozoan. Even the mesh itself is included in the coverage. And then Sebastian had an increase in what seems to be sponge and oyster, so that middle section really filled out there. And then for our June assessment, the simper analysis revealed that barnacles, biofilm, oysters, and sponge were driving the difference as well. And again, visually, the photos on the right reveal that there was an influx of sponge for Cape Canaveral, and also more so biofilm for our southernmost location in Sebastian. And then all across the board at all docks, looking at the graph, you can see there was an influx in sponge and biofilm at all locations, especially. All right, so overall, organism diversity was determined through a Shannon-Wiener Diversity Index conducted through our studio as well. In general, the greatest diversity was observed in June, which was our warmest assessment of 87 degrees Fahrenheit. And there was a significance in diversity from all locations from October to June. At the end of the experiment, we looked at mat cementation, and there was an increase throughout the study. At the end, Cape Canaveral had greater than 70%, while the other 3 locations end up having greater than 80%. And I think it's important to note here that while Cape Canaveral had more of a simplistic community, it still had a great amount of cementation that potentially could lead to it cementing itself to the piling. Right, just to conclude and drive everything all together here. Overall, for the biodiversity, our dominant organisms found throughout the entire study were barnacles, encrusting bryozoan, sponge, biofilm, and oysters, and the highest diversity was observed in June. In terms of cementation, sponge coverage was dominated in the cool assessment period of February. Barnacle, sponge, and encrusting bryozoan dominated the warmer months of October and June. And at the end of the experiment, there was an increase in cementation greater than 70% at Cape Canaveral, and then finally 80% at the other 3 locations. So with that is everything I have for you on the background of living docks. So taking the information that we know from this, Sarah's going to talk to you a little bit more about how we're going to apply it here at Florida Oceanographic.
All right, so thank you, Morgan, for giving us that introduction and talking about the previous research that's been done. So why do we care? Why do we want to bring living docs to our area? What are the benefits that we see? What can we see happening? So the first and foremost is creating lagoon health awareness. A lot of this is volunteer driven. We have volunteers helping us create those mats, as well as our docs are provided by homeowners who, for our preliminary study, we're hoping they can give us their docs as well as their time helping us take water quality measurements. And so a lot of it is learning about how healthy our lagoon is, as well as creating those benthic communities, those nice biodiverse communities. It's not just all about the sponges and the oysters that we create, but the ecosystem that they create themselves. So those communities will actually help bring in larger fish, seabirds, as you can see here, maybe even a manatee, dolphins, and just creating that nice benthic community, as well as, of course, what we really want to do is clean the lagoon using those filter feeding organisms to kind of clean our water, take up those nutrients, take up that chlorophyll, and stop the bad things that are happening from the nutrient runoff and the urbanization. Just doesn't like. Once again, I'm having technical difficulties. Let me stop sharing again and reshare. Sorry, everybody. There we go. So this project that we're also starting down here is going to be in collaboration with Florida Tech. So Florida Tech are the creators of the Living Dock, and we're hoping to expand this program. So we have those docks that you saw on the map earlier that Morgan showed in the Northern IRL. As well as we'd like to expand this down here and eventually expand it to the mid lagoon. So with this project, we'll have an increase in data collection. So looking at water quality, not only in the Northern IRL, but also the Southern IRL, as well as different organism identification. So we do have different potential organisms down here. In the Southern IRL, we have a more subtropical climate, while in the Northern, they have a more temperate. So hopefully seeing different organisms, as well as potential master student involvement, involving new scientists, creating more people, and just doing more research involved with this. So our current research questions for this study are similar to what Morgan talked about before, just bringing it down here. So looking at what organisms have settled on the maps that we put out, as well as how do these benthic species vary spatially and temporally. So how does this change through time? How does this change depending on our dock location? So what this will look like for our experimental design, once again, we're doing this as a short pilot study, just a 1 year to see if this will work in our area of the lagoon. So we're doing a call for volunteers. We actually have a link. Morgan will be putting that in the chat shortly for anyone that is interested in donating their dock. If you have access to a private dock or know someone that does, please share with them if they're interested and available to give us their time, about an hour a week.
That was me. I apologize.
Oh. No, that's okay.
I was trying to admit someone from the waiting room.
No, that's all right. Did you miss anything? I was just talking about dock locations.
No, we did not.
Perfect. So once we have our volunteers, of everyone that's volunteered, we have those locations, we'll go out and start to do assessments on those docks to see what'll work. So looking at location, the size of the dock, how long it is, what kind of bottom type is there. So is it seagrass, mud, an oyster reef already, or other factors, including just kind of what benthic organisms are already there. Sorry, it's not advancing the slide for some reason. Sorry, everybody. I don't know what's happening.
Do you want me to try mine?
Yeah, we'll have Morgan try and pull it up here in a minute, but I will keep going until she has it up. Sorry, everyone. Everyone knows technical difficulties in this time with Zoom. All right, thank you, Morgan. So along with that experimental design, once we've chosen the docks that we think would be best suited for our preliminary study, we'll attach 6 to 10 oyster mats onto pilings at those docks. And we'll go out and do those benthic community assessments similar to what Morgan talked about that was done in the Northern IRL. So for those initial assessments that first year, we're going to be targeting stations near the pre-existing Erlon and Orca water quality monitoring stations. So for those of you who don't know, those water quality monitoring stations take things like temperature, salinity, pH, dissolved oxygen, nitrates, and phosphates, which are our nutrients. And they actually take measurements every 30 minutes to 1 hour. So getting that fine scale variability. We're hoping to leverage this in our own study. So as well as we're asking those volunteers to go out and take water quality weekly, looking at this at fine scale to see the variation that we have. We hope to get volunteers to have 6 docks close to each location and choosing them near, once again, those target water quality monitoring stations. And then we'll go out monthly as our research staff here at Florida Oceanographic and take more fine scale water quality. So looking at nutrients directly at those docks, as well as chlorophyll, so our algal abundance right next to our living docks themselves. As well as we'll be taking those quarterly benthic community assessments, seeing what's there and seeing how that changes. In addition to looking at those living docks, we'd also like to add an oyster gardening component to this. So oyster gardening is another way to help clean the lagoon. Oysters can actually filter up to 50 gallons per day of water. And they're filtering things, once again, like those nutrients, depositing them, as well as filtering the algae, so helping those algal blooms. And the reason oyster gardening is so great is that it actually helps protect those oysters. So here on the left, you can see an oyster shell that has spat on shell. So spat is those baby oysters. Those oysters have a larval phase where they'll swim around, and then they're attracted to that calcium carbonate and eventually settle on that oyster shell. They'll live there the rest of their lives. You can see, once again, that spat is highlighted with those red arrows on that left photo. And so oyster gardening helps protect these baby oysters. So it helps with things like competition as well as predation. Volunteers will keep them off of their docks and clean them weekly, and they'll keep them for 6 to 9 months. So with the addition of oyster gardening, the questions that we'd like to ask here is, does oyster gardening impact the established benthic community on these living docks? Are we going to see a greater population of oysters with the presence of live oysters? As well as looking at the differences in water quality at our living docks that do not have oyster gardens and those that do. Are the oysters actually helping to filter this water, or is it the entire benthic community overall? So in addition to that experimental design, half of the living docks that we choose for that initial assessment will also receive an oyster garden. They will receive spat on shell, so we'll have that larger oyster shell and give them that baby spat on there to grow over a 6 to 9 month period. Once again, half of those living docks that are chosen for those locations will receive an oyster garden to determine those potential effects that are from live oysters on living docks themselves, as well as this will include having volunteers grow out that oyster spat, those baby oysters, as foster parents for about 9 months, giving us time weekly to clean those cages in addition to taking that water quality. And hopefully at the end of the experiment, we'll have nice stable oysters to return to our locally restored reefs that will continue to up our oyster population. So for this program, we intend to leverage an existing program that we have, the Florida Oceanographic Oyster Restoration, FLOR, which is where we collect shells through a shuck and share program from 10 local restaurants weekly. In 2021, we were actually able to collect 44 tons of shell. We intend to use this shell to make those oyster mats for the living docks. And so drilling holes in them, zip tying them to the oyster mats and connecting to pilings, as well as using them for our oyster spat. So currently Florida Oceanographic monitors oyster spat at some of our restored reefs. We do this through oyster teas. You can see this in that center photo. We have an oyster tea set up there at one of our restored reefs. It has 7 shells on each side hanging from a galvanized wire. And this will actually attract that oyster spat. It'll settle on that shell. We check these monthly. And so for this initial project, for that 1-year study, we're intending on using wild spat caught on these oyster teas for the oyster gardening. So you can see here on the right, here is one of the shells from our oyster teas, and kind of all of those oval shaped circles are actually oyster spat. So this one has a lot more spat than that one you saw previously, but once again, using this for our oyster gardening program. So to give a quick timeline of what this project is going to look like. So starting right now, we have that call for volunteers. If you have a private dock, please, please, please sign up. Even if you are not in the areas that we listed, we do hope to expand this program in the future after our first year study. So please sign up. We will keep you in the waiting to get a living dock once we've done our initial study and see what will work. We're also starting to have volunteer events to start making those oyster mats as well as cages for our oyster gardening. In the spring, we'll begin doing our dock assessments and site selection. So hopefully we'll have volunteers close to those long-term water quality monitoring stations, and we'll start looking at the docks that we have. So looking at the water depth, how long the dock is, what kind of benthic organisms are present, and just how well we think that it'll work for a living dock program, as well as we'll continue to have those volunteer mat making and oyster cage events. In the summer, we'll finally get to do our dock installation. So going out to our chosen docks, hopefully having large volunteer events and just attaching those oyster mats. Then in the fall, we'll do our initial benthic community assessment. Once again, this will be very similar to what Morgan talked about that has been done in the Northern IRL. We'd like to do it very similar so that it's a comparable study. And then in the fall as well, we'll start giving out our oyster gardens. The reason we're not starting our oyster gardening the same time as our dock installation is to better benefit our oysters. So in our area, oysters actually grow better during the winter months. This is because it's cooler temperatures. They're not trying to fight as hard against such high temperatures, as well as a more stable salinity. There's not as much fresh water coming in during our winter months. So to kind of remind you of what we'll be collecting, especially when talking about those initial benthic assessments, we'll be having our volunteers with docks doing water quality. So this will look like something similar to what we have with our water monitoring program. Our volunteers will be collecting temperature, salinity, pH, and dissolved oxygen. Then monthly, our research staff will go out and take more of a in-depth water quality sample. So looking at everything that our volunteers have, including nutrients, so nitrates and phosphates, as well as chlorophyll, and doing those community benthic assessments with, again, seeing what organisms are there, seeing what's not. And then monthly, we'll go out as well and do oyster mortality on our garden oysters. In winter and spring, we'll continue to do those benthic community assessments, see what's there, see what's not, see what's changed. And then finally, in the summer of 2023, that'll be the completion of this pilot study. We'll collect those garden oysters that are hopefully large, stable adults that have been taken care of well by their foster parents and return them to their local reefs, as well as we doing our final dock assessments. Now, doing those dock assessments doesn't mean we'll be taking the living docks off. They'll actually remain there. They're part of the ecosystem. As Morgan showed earlier, there's a high likelihood that they will be cemented to the pilings and just becoming part of it. So becoming part of that ecosystem, and we plan to leave them there and hopefully adding more living docks into our area as well as further north. So what are our expected results? What do we hope to see from this? How do we think that it will be different from what has been done in the Northern IRL? So we expect an increased abundance and biodiversity of those benthic organisms. The reason we suspect this is because the Southern IRL, where we are in the St. Lucie estuary, is more of a subtropical climate. So those subtropical temperatures are a lot warmer than we see in the Northern IRL, which results in increased growth rates. We also expect there to be just more diversity because of a higher water influx. So there's more flushing in our area because of that inlet. The water is not as stagnant. With that more flushing, we expect more larvae to come through and just more organisms in general. We expect that increased diversity and abundance to lead to an increased water filtration. The more organisms you have filter feeding should result in more filter feeding, as well as that increased diversity. When you see drops off in different species, different times of year, hopefully that diversity will help pick up that slack. We also predict that the presence of oyster gardens will increase our oyster abundance on our living dock mats, just because the presence will hopefully lead to more presence on living docks. Oysters can actually reproduce after only 4 weeks. And so hopefully there'll be a source of larvae as well. We also expect them to have an increased water quality at our living dock sites, just because the the oysters are able to filter so much. They're kind of a workhorse as far as that goes. So what's the big picture? Why do we care? Why do we want to bring a living docks program in oyster gardening down to our neck of the woods? And really it's to determine when and where these filter feeding communities exist and what future steps we can take to restore our lagoon. Living docks is an easy program. It doesn't require any permits, and it really helps our filter feeding community help filter those waters and take out some of that nutrients and the algae that's coming from our urbanization and our nutrient runoff. So after the 1-year study, our pilot program, we hope to have a peer review publication. We hope to have this publication to kind of share the science that we find down here, hopefully with expanding it up towards the lagoon, not just the northern and southern, but hopefully in the mid lagoon as well as sharing our science with other areas that have water quality issues outside of the IRL. Once again, we hope to expand these programs. So this is our first initial year, but we hope to have more of these living docks, more of these oyster gardens. We just need to kind of understand how they work, who's there, and what time of year they are. So with that, I would like to thank you all so much for coming to learn about living docks in our oyster gardening program. If you have any questions about past research, please feel free to reach out to Morgan Gilligan or other collaborators that have done work on living docks in the past, Dr. Weaver and Dr. Hunsucker. And if you have any questions that you don't think of right now, and if you'd like to ask in the future, please feel free to contact me, as well as if you are interested in becoming a living dock volunteer, please visit our website. I believe Morgan also put that link in the chat. But thank you. And at this time, Morgan and I will take any questions you have.
Great. Thank you so much, Sarah and Morgan. We have a bunch of questions in the chat for you. So I'm going to start with our first one. I'm not sure if you're going to be able to address it, but someone asks if you're able to discuss the effects of the 7.2 million gallon sewer spill in Titusville by the Max Brewer Bridge. Said it was months long sewer spill and believed it was the cause of a reduction in Secchi visibility, which may have eliminated the seagrasses in Titusville. So I know it's outside of the range of this research project. So I'm not sure if you can address it at all, but it was a question for you.
So from my understanding of the increase in nutrients, that also could lead to the harmful algal blooms as well. But either way, if there's an increase in turbidity, that would drown out the light that certain ecosystems need, such as your seagrasses. In terms of the benthic filter feeding community, they would help to filter out these nutrients, but it could have, like you said, been on such a large scale that it just overwhelmed everything. And since this community is more so depleted, which is why we would like to enhance it, to bring more awareness and to also, enable more filtration for events like this. Yeah, I don't think I can fully answer that, but yeah, I hope that helped a little bit.
Yeah, I appreciate it. There was also a question related to that. Specifically, are there any oyster or clam projects being done in the Titusville North IRL region that you need volunteers to help with?
Oh, yeah. So Brevard Zoo actually started their clam restoration projects. I don't know if they take volunteers out with them. And then we are working on our own clam restoration projects down here at Florida Oceanographic as well, for deployment over the summer. So I would stay tuned for that. We may need volunteers.
Perfect. And thank you. While we're doing questions, you all may have noticed that I posted the evaluation poll. So thank you for those who have already completed it. And if those of you can continue to do so while we go through the question and answer, we'd appreciate it. Lorraine asks, the Cape Canaveral benthic community assessments did not have oysters present over your temporal sampling. What do you think is going on, Morgan?
Yeah, that's a great question. So in my first initial assessment in October, there actually was an algal bloom. It was a cyanobacteria. And so my theory is that a majority of what was living there did die off, hence the more simplistic community. something I did forget to mention at the end in the summer, we actually did see a few oyster spat there. There was a very thin blue line on the graph. You may have missed it. But that was really exciting. So it proves that even though the mats are out for, a long period of time, it still gave a nice settlement place for future oysters just passing by. But there is not an established oyster community at this dock. So a majority of the docks that we go to, since it is volunteer driven, already have an established community of oysters. You see them on the rocks, etc. So that allows for the spat to travel and eventually reach the mats. So this was the one location where there wasn't anything. So to find spat in the end was really exciting. So they eventually somehow made their way over.
Great, thank you. Going back to the Northern IRL, do you think that the pollution in the north part of the IRL, such as in Cape Canaveral and Titusville, is preventing the oysters from growing? It's strange that oysters do not seem to grow there anymore when they used to grow in great numbers before 2000.
Yeah, it could be. That is also a little bit of a loaded question as well, but they can be quite sensitive from what I found. It's just, yeah, the right timing and cues and also nutrients and predation as well involved. So there's a lot of little factors that add up when it comes to restoration projects and specifically oyster restoration. So I would say, yes, it has partially due to that, but it also could be other factors. Were there, reefs present there to begin with? I know Linda Walters at UF or UCF does a lot of work there as well. So it may be worth it to contact her and reach out and see what restoration project she's going on and what she's found as well.
Thank you. Ryan Goldman asks if there is a specific oyster species that you're targeting.
Oh yes, Chrysostrea virginica, sorry, Latin. The only other one that I know of is Chrysostrea gigas, and those are used up in the Chesapeake.
Those are West Coast. So we're targeting the eastern.
Oh, Sarah, yeah.
Sorry, we're targeting the eastern oyster, Chrysostrea virginica. That's what makes up most of the oyster reefs that you see around here. There are some species of oyster around here that settle in mangrove roots, but we'll be targeting the eastern oyster.
Okay, thanks. So many questions. Vivian Main asks, Sarah, during the 9-month study period, will the oyster spat in the cages reach sexual maturity and spawn?
That is what we're hopeful to happen. So oysters are actually protransitic hermaphrodites. That means they start out their life as males, and as they grow, they become females. So hopefully they will grow. They'll usually probably all start as males. Hopefully we'll have females and they'll grow to that, but yeah, we hope to get larvae from them.
Rachel Harris says, great project, Morgan and Sarah. So happy to hear this work is active in the IRL. Ryan Goldman asks whether or not this program would be applicable down south in Broward and Miami-Dade counties. I don't know if you're able to address that.
I think the program could move down there. I mean, that's part of what we're testing to see, can it be applicable in our area? I think a pilot program in that area would work great to kind of see what benthic community you're getting. Is it actually filtering the water? But I think doing a pilot program, seeing what's there, seeing if it actually filters, and if it all works out growing, it was a great idea.
Yeah, I would say from my experience in that region is salinity differences, especially in Biscayne Bay, are much different and higher than what we see in the IRL. So that could be a limiting factor. So you might want to do those spat teas before you actually go out with a full-blown project, just to make sure the oysters are viable, because we do not have large oyster reefs in those regions like we do in the IRL. We have a bunch of links. Lorraine puts the restoreourshores.org link in. David Herschel asks, what's the time frame between taking spat from the PVC teas to placing them in the gardened oyster reefs for dock deployment? If the time is significant, how are you keeping them alive until that process takes place?
Yeah, of course. So we've actually already started collecting some of the spat we plan to use in the oyster gardens. We're keeping them here at FOS. We have fresh seawater tanks. So they're receiving water directly from the beaches, actually, so a little bit cleaner than the IRL. And they're getting the algae from that. We're growing them and cleaning them, and we'll eventually place them out in, once again, September, October.
Okay, and Carly Nielsen says that the Brevard Zoo does take volunteers for clam monitoring, and those who are interested should email the Restore Our Shores program. Caitlin Rancher asks or says, important and exciting work. Great job. Catherine Owen asks if there's any activities going on in Volusia County for volunteer work. Do you know?
I'm not sure off the top of my head. If there was, I think, yeah, Linda Walters or even the Brevard Zoo would be your best bet to ask.
Okay, great. We've got a two-part question here from Casey Niffen. Says, thanks for sharing your work, and I look forward to volunteering. Two questions. Will docks at county parks, such as Peck Lake Park, be utilized in the Living Docks project if there are volunteers who are willing to check those sites? So I'll let you answer that one first, and then I'll go to question two.
Thank you. Yeah, so it depends. I feel we have done in the past docks in Melbourne Beach, but we had to contact the mayor specifically and go through them. So instead, it has to be the owner, I would say specifically for that specific dock that we'd have to contact and get a hold of. Just because we go out and do the assessments, even though it is a public dock, we still like to inform people, you know, what's going on, and we are on their property, essentially. So I would say potentially, yes, it may take a little bit more effort to get communication started, but I think it would be a great pilot project to start.
Great, thank you. And part two is, do you have specific messaging to boaters to promote living docks? Many that I have talked to loathe oysters because they pose a risk to their boats while docking, scratching the gel coat, etc.
Yeah, so it's really funny. I think, yeah, the fouling community is seen as a nuisance, or the unwanted weeds, if you will. Because yes, everyone, they stick to everything or on everything, or if you're a scientist, they are on all your sensors that are in the water. So advice, I think, would just to be educate people where you can. If there's some way to, and I feel like we have not found a viable method yet to salvage, especially the oysters, you know, since they filter the most water off of the boats themselves. But I think advice would just be continue the education, continue reaching out, and just, you know, be an advocate for filter feeding organisms since they are low on the totem pole already.
Great, thank you. And we have a suite of resources and volunteer opportunities that have been listed in the chat. So thank you everyone for putting all of those links in there, up and down the entire IRL, all the amazing volunteer programs that we have. And Sarah and Morgan, thank you so much for your presentation and for all of your work in the IRL. If you don't mind, maybe we'll hang on for a couple more minutes. And until next time, everyone, hopefully we'll see you March 15th for our continuing the oyster conversation, or in person March 1st with our field trip. So thanks, everyone. We apologize for the technological issues today.